Thank you. Yes, I want to say a huge thank you to all of the organisers, Matthias, Marty, and yeah, thank you for the invitation. This is really great for me to come here. I've been head of department for a while, so this has been really refreshing and to think about these issues and do some research. And thanks to everyone who's got a lot of things traveled a long way as well. So thanks for being here. It's a lovely event. I'm really looking forward to it. So I wanted to kick the event off with a fantastic talk. So I managed to do that by finding a fantastic talk and then linking to it. So I think my talk's a bit mediocre. You can check this one out later. This is a really wonderful talk about climate psychology and conversation. But what I was particularly interested in was the power of storytelling. If you watch the talk later, you'll see how that features. But it strikes me that's something that we can do in academia, but we don't do so often. So most of my talks over my career have been sort of rather dry analytic arguments, or at least there's been an attempt to be, and that's what I felt I should be doing. But I hope you'll forgive me for experimenting a little bit today with something that is a little bit more like a story. And I call this 5 Epiphanies in the Quest for Scientific Truth. And perhaps this will appeal to some of the younger early career scholars, because this is sort of, in a sense, this is a story sort of taking you to a trajectory in my own learning as an academic and as a human being more generally, as somebody who was once very young and very passionate about the idea of scientific truth and exploring the world and trying to distinguish truth from falsehood. And following my thesis, I wanted to get into what I thought was the key debate about the relationship between science and truth. And so, although my thesis was about inconsistency in science, which is sort of tangentially related to that question, I then sort of followed up with these papers which were squarely in the scientific realism debate, and an attempt to make some progress in this question and defend the idea really that science is in the business of finding out truths about the world and is by and large successful. Now, this was the starting point, but it's been an interesting journey with unexpected twists, plus the 5 Epiphanies. So I thought it would be interesting to explore what these have been. In some cases, I suppose I feel like I wish someone had told me these things at the beginning, because in some cases they were basic assumptions I had about the contours of the debate and what I was doing and what would constitute progress, which later on I doubted, and therefore, at the extreme, you could call this some of my time spent a waste of time. And, if that's the case, I was working hard based on certain assumptions which I later cast out, and then my later self is thinking, if only I rejected those assumptions earlier, I could have done more productive work, for those 2 years or whatever it was. So let me take you through these. Some are more epiphany-like than others, but I'll let you be the judge. But some of these were quite sudden U-turns in a sense, or a moment of awakening, perhaps. Now, although I call them moments of awakening, you may think that it's the new idea I have, which is really the mistake, but that's for you to judge. And the first one of these is the very idea that there's something deeply wrong with the scientific realism debate. Now, quite early on, I was aware of certain papers which had been written, which are putting this idea forward, at least jointly, in different ways, perhaps. But in this paper by Arthur, in particular, this paper by Howard Stein, which I'm sure many of you, all of you will know, and other papers which sort of make the claim that maybe scholars are talking past one another, progress isn't being made in this debate. It's sort of a bit of a game that goes around in circles. Now, my initial assumption as an early career scholar straight out of my PhD was that this couldn't quite be the case because there was all of this literature and many clever scholars involved. So how could it possibly be the case that they're sort of wasting their time or playing a pointless game? That just couldn't be the case. So this was a suppressed. But I just reject the idea that there's something deeply wrong here. And so perhaps more subtly, I thought, well, perhaps certain ways of doing it are flawed. So some of you all know this distinction between wholesale arguments, retail arguments, or local versus global. I mean, it could easily be the case that there's some ways of doing this debate that aren't fruitful, and other ways that are fruitful. So that doesn't mean the debate's flawed. It just means that, of course, there are better and worse ways of trying to make progress. I suppose it sort of I slowly came to the thought that many ways of doing it are flawed. But then I thought, as my career was progressing, maybe I just want to ask different questions. So those old questions are still fine, but I've taken a trajectory, as many philosophers do. You'll know this yourself. The questions you started with that seem so important. Well, you don't move on to some other questions which seem perhaps more important, but it's just a natural progression for all of us, I think. But I did finally come to the conclusion that most of it was flawed. Now, this is up for debate during these next 2 days, so but I might as well put this on the table as something that I feel like I did reach in a sense. Well, I think the observable and unobservable distinction, it has its historical roots, but I've grappled with this quite a lot and felt like there's too much weight is being put on this distinction, and ultimately that distinction is not able to withstand the load that's being put on it in many of these arguments. I did feel in the end that there was too much talking past one another. So this is sort of that our Stein paper, the title of that, yes, but, it's like, always say yes, but, whatever the other person says, and there's this question of progress, which has really bothered me in philosophy generally, but this sort of, as a philosopher, it's always sort of lurking over you, are you actually making progress? What constitutes progress in philosophy? Or, does everything sort of go around in cycles? Are there just, new ways of looking at things, new perspectives, but nothing that could actually be called genuine progress? Fashions, more like fashions. So this was there and in the background, and this became more and more worrying for me the longer I spent in this debate. And this quote from Iris Murdoch's The Nice and the Good sort of rung true at some point. She says, there's certain areas of scholarship, early history is one and Roman law is another, where the scantiness of evidence sets a special challenge to the disciplined mind. And then she says, it is a game with very few pieces where the skill of the player lies in complicating the rules. Now, I think in the realism debate, maybe we can all agree that the rules are complex and the rules keep getting changed. And this is perhaps why it's hard to see progress. What seemed like a good way to progress a few years ago, now the rules are different, the positions are different. That target that you were attacking, that doesn't exist anymore. So there's these shifting targets, and this was the worry. Now I'll go into some of the specifics as we progress today. But here's just one illustration of something that made me pause for thought. And if we imagine a realist R and an anti-realist A meeting each other and sort of having this debate. So there's self-professed realists and anti-realists, these two individuals. And so when they meet each other, the assumption is that the realist thinks that most of our current science is getting at the truth, at least approximately, especially in our mature theories or something like this. And the anti-realist is more skeptical and far less willing to believe scientific claims. And now, if we take the full set of scientific beliefs of the realist and the anti-realist, as this large ellipse here is one set of beliefs. This is one of the individuals, and the small one is the other individual. Then, of course, the natural thing is to suppose this is the realist. They have loads of scientific beliefs because they're the optimist, and they think science is getting at the truth, and they want to say all of these things that we should believe in because science is so successful. And you think this is the anti-realist because they're much more skeptical. They share some beliefs, of course. And then there are things neither of them believe in. But this is what you would think. And one thing that dawned on me is that it's perfectly possible, given the contours of the debate and the position, that this could be the realist and this could be the anti-realist. This was frustrating to me because I thought this is the whole opposite of what I expected when I started the debate, and also for, I don't know, 5 years or so of being in the debate. So let me explain how this could happen. I think this could happen because some anti-realists are inspired by Van Frassen's observable unobservable distinction. And the anti-realism it pertains to in principle observables. When it comes to observables, they have no problem believing things. So, for example, did dinosaurs once roam the earth? This kind of anti-realist can be, oh, yeah, of course I can believe in that. The evidence is overwhelming. They're observables. My skepticism pertains to in principle unobservables. Not unobservables in practice, but in principle unobservable. So this anti-realist also believes that the Earth has an inner core and an outer core, because they're observable. They're, not in practice, but in principle. You could cut the Earth in half and you'd see them. Yeah, they're macroscopic. So the anti-realist believes in loads of stuff that is about observables. And because they interpret the observables very broadly, that's loads of stuff. Like I say, the inner core of the Earth is observable. And so if the evidence is strong enough, the anti-realists can believe in that. They're an anti-realist because they think we can't have knowledge of in principle unobservables like electrons and space-time, things like this. Whereas the realist thinks you can have knowledge of those things. Now the realist doesn't believe in a lot of this stuff because realists only believe in stuff when the evidence is strong. Okay? And so realists is within the allowances of the realist position that the realist sets a high bar on when the evidence is strong enough to justify belief. And in this case, when it comes to claims about observables, the realist happens to set a higher bar than the anti-realist. So the realist is really cautious. They only make a realist commitment when the evidence is really strong. I mean, and that could take lots of forms. It could be that the realist only makes a commitment when there's been an abundance of novel predicted successes or something, whereas the anti-realist doesn't do that. So the realist is more cautious, but the realist believes a few things that the anti-realist doesn't, such as in nuclear fission of uranium-235, the uranium nucleus divides into pieces, releasing energy in the process. The anti-realist doesn't believe in this because it's about in principle unobservables, but the realist does. So this is the kind of scenario that I thought was confusing and annoying, and you might want to think this is a bit unrealistic. In most cases, the anti-realist is going to be more skeptical generally than the realist, but this is within the contours of at least one version of the debate. Anyway, this Yeah, in the first chapter of my book, I list these 30 examples of things that I think most realists and anti-realists will believe, because most of them are sort of just high school textbook scientific facts, and most of them are about observables anyway. So most anti-realists will say that's the kind of thing I can believe. You know, Tyrannosaurus Rex did exist, and even the Milky Way is a spiral galaxy. There's another observable thing that is only unobservable in practice and not in principle. So, but when you think about the full collection of possible statements that you could make, including things that I call singular scientific facts, and there's a whole list of these in the book. But here's a couple. The Earth has a liquid metal outer core. It could be the case that the anti-realist believes in more of these than the realist. As they say, realists don't believe, they don't make doxastic commitments incautiously. Of course, that's not a defining aspect of the realist position, to be incautious about making belief. And what gives them caution is that they demand that there's a lot of strong scientific evidence. So a realist can actually be quite circumscribed in not believing, scientific claims unless a lot of stringent conditions are met. So this sort of explains this passage from my book. I think this is the start of chapter 2, where I sort of go into the realism, anti-realism debate, and why I don't think of this book as a position in that debate. And I don't want to call myself a realist anymore, because that term has so much baggage that I really want to leave behind. And I'll just give you the start of this chapter in case you haven't seen it. So anti-realism is a position defined by its opposition to realism. But realism, on the face of it, is the position according to which we have good grounds for believing that the entities and processes posited by our best scientific claims are real. So the anti-realists, by contrast, claim that we do not have good grounds for believing that the entities processes posited by our best scientific claims are real. Incredibly, this is already a misleading construal of the debate. So I go on to sort of explain, like, the word incredibly there is sort of, signals my frustration that even after being in this debate for years, I still felt like I didn't really understand the debate, or maybe it had just changed, or maybe there were just so many positions that, or maybe it was the case that everyone in the debate had a different position. So there wasn't a realist and an anti-realist position as such for me to engage with. I felt lost after being in this debate for years. It's like, at some point, I kind of had the self-confidence to think, this isn't just me not getting it, it might be the debate. So that's where that comes from. So maybe the debate is flawed. So second epiphany was that I thought I had a great with Kyle, and my advice about almost everything, like Kyle can correct you on this in due course. And we've had discussions about this. Maybe almost everything is too strong, but still, I mean, this relates to the previous point, of course. Now, there are certain specific statements which can be taken out of context, which would seem to signal that, for example, Kyle and I are dramatically opposed. And I think this presents the debate in a neat way for early career researchers or students, who sort of say, here's one extreme, here's another extreme, how are we going to resolve this? But what I felt was that despite statements such as this, our own historical successors will someday view even the leading scientific theories of our own day in very much the same way that we regard those of our historical predecessors. If you look into the details of Kyle's work, and there were of course many nuances, and for many nuances in realist positions, so that to cherry pick a statement which is like uber realism again is unfair. But then often the debates are defined by these extreme statements. Here's what the anti-realist thinks, here's what the realist thinks. Couldn't be more different. But I don't think that's really the case in the end. But here was another one. Our theoretical conceptions of nature will continue to change just as profoundly and fundamentally as they have in the past. So again, I don't want to be unfair, as I say, I think I love Kyle's work, but you know, you can cherry pick statements and it looks like we're dramatically opposed, whereas in the details, I don't think that's the case. Something I explore in these two sections of the book, which I'll sort of summarize today, but can't go into in full detail. But yeah, standard skepticism, and I think Van Parsons as well, as two sort of big actors in the non-realist camp, if I may say that, they're nuanced, they're circumscribed. There were qualifications. So what I say in the book, standard skepticism is very much circumscribed, most often applied to entities and processes that any conscious realist would also be inclined to be skeptical about. Again, it's that point that as a realist, when I was a realist, if I'm not now, I don't know, I don't like that term anymore. But if I was a realist, then I always wanted to be cautious. You know, I didn't want to sort of have egg on my face saying, I believe X. And then a couple of years later, someone's like, that's been overturned now. And I was like, well, I overcommitted. Of course not. You know, nobody wants to overcommit. It's just getting the balance right. And I think that balance is something that's worth talking about today, tomorrow. It's something that's come up in some of the literature already. The idea that the realist wants to find this nice middle ground, not overcommitting, not undercommitting. I think so does the anti-realist. The anti-realist doesn't want to say, you know, I'm skeptical about everything, you know, climate change, I'm an anti-realist, you know, of course not, dinosaurs existing, I'm an anti-realist. No, the anti-realist also wants to get the balance right between being appropriately cautious and skeptical, but not too cautious and skeptical about science generally. So they're actually on the same, the realist and the anti-realist, I think, are on the same journey, just coming at it maybe from two different directions. And I think the agreement comes in two forms we should distinguish. Agreement concerning many scientific results we should believe given the evidence, and also many scientific results we should not believe given the lack of evidence. So in the first count here, results we should believe given the evidence, Kyle has a lovely paper on fossils, and you know, we both agree that we know where fossils come from, broadly speaking. Of course, there are tricky questions about the details, but broadly speaking, we know where fossils come from. And things we should be skeptical about. Of course, there are many things that realists say we don't know. We don't know that yet. You know, the evidence isn't strong enough. We don't know what caused COVID yet. You know, the evidence isn't strong enough, or whatever your favourite example is. So Stanford and I seem at first like great adversaries in the science and truth debate. The titles of our book, Exceeding Our Grasp and Identifying Future-Proof Science in Opposite Directions. He is self-described as an instrumentalist, where as I have in the past, self-described as a realist. But behind the isms, the headlines, and the soundbites, there's very considerable agreement. So this again goes back to me thinking about, you know, the early career scholar, you know, myself right at the start. I think I assumed that there was this dramatic contrast, and it was only much later that I thought that's more about the titles we give ourselves for whatever reason. I'm a realist, I'm an anti-realist, I'm an instrumentalist. The headline statements, which actually do not do justice to the substances of the positions. Actually, you know, we don't disagree nearly as much. It's more like we're like the Judean people's front and the people's front of Judea. Like, you know, we agree on almost everything, but we're very angry about those details. Maybe. Okay. I mean, so maybe this says more about the way that the debate has evolved rather than signaling there's a serious problem with the debate. What you might say, as Stanford Kyle does quite nicely in this chapter in the book I published with Tim Lyons, is that it's not that there's something deeply flawed here, but rather that, these extreme positions have just come closer together from these two different directions, and actually that agreement signals the debate coming to some kind of resolution. And maybe that is progress. That's what progress should look like. It's like this thinking we thought we were dramatically opposed. You've nuanced your position, I've nuanced my position, and we're sort of meeting somewhere in the middle. Who cares really if we aren't exactly there? We're never going to agree on everything, but maybe that is progress in philosophy. And along one of these many meandering paths in the scientific realism debate, this is a partial resolution of part of that debate. So the third epiphany was about naturalism, and I originally thought I was if you like a classic naturalist. Now this term has many definitions, many formulations, but I thought that originally for me scientific evidence was paramount, and any philosophy I play was going to be based on the science. So I was predisposed to think positively about science and its achievements rather than looking at things and thinking that's probably not true. I was impressed by science. I wanted my philosophy to be informed by that. So I at one time called this science first philosophy of science. Don't do any philosophy of science unless you've done some science first. Science can be very nuanced, and we don't want to say things about science without understanding the science. That kind of position. So it's avoiding armchair philosophy. Some of the old debates in philosophy of science where philosophers went whole careers without ever talking to a scientist or really doing any science, which is I think largely being cast aside these days. But I like quotes such as this by Peter Lipton. At the end of the day, the only evidence for the truth of scientific theories is the evidence that scientists use, and the only positive arguments for scientific realism are the arguments that scientists make. I thought that sounded good. And the only sensible way to find out whether a scientific claim is true is by looking at the original scientific evidence previously offered by scientists. So it's anything. And with this kind of focus on the scientific evidence being paramount, which is something I did do a dramatic U-turn on, which I'd like to explain. This I think counts as an epiphany for me. Now, I still have sympathy for naturalism in some of its forms, and as I said, this is a much contested word. So what I say, this is again from the book, even hard-working scientists only have time to properly consider a small fraction of the overall first order evidence relevant to any given scientific claim. But we want to base our conclusions on the entire evidence base, ideally judged from a variety of different perspectives. So the thought here was that never mind the philosophers, even the scientists in a debate don't have time to properly consider all of the evidence for any given scientific claim. At least not individually. They might do it sort of second hand or third hand through colleagues or other teams that they trust, and they're making judgments about what they should believe in their own field. But in that case, they're not looking directly at the scientific evidence themselves. They're sort of getting it second or third hand. And what I said here is the only option is to indirectly access the overall evidence by assessing the judgment of the relevant scientific community, since that community taken as a whole has directly assessed all of the first order evidence from a variety of different perspectives. So if possible, you would spend all of your time, which would be more than a human lifetime, looking at all the evidence for yourself. But even then, it would just be one person's perspective. And ideally, you want to say, look, I have one perspective on the evidence. What's your perspective? What's your perspective? And then if we all agree, that's really significant. Because from coming from these dramatically different directions, which would all agree that T-Rex really did exist, or whatever it is. And that's more significant than one person. But it's the whole community endeavour which really matters. Because that's where you can talk about all of the evidence from a variety of perspectives. So the proposal is that we should identify scientific facts and a very strong consensus. This was second order, not first order. So this was really the pivot for me from moving to things like novel predicted success, which was an aspect of the first order evidence, which I did focus on quite strongly for the first 5 years more in this debate, to thinking that the scientific consensus is extremely important, since in forming that consensus, the community will have considered any novel predictive success, also any expansion success, other types of success. Confirmation is a very many heterogeneous thing, to quote Kyle. I think we agree on that as well. Evidence comes in many forms in science, not just predictions and explanations, but in many subtle forms and sometimes surprising forms. And if a consensus forms over many years of debate in the scientific conferences and in the literature, then all of that has been somehow taken into account. So I'll come back to the idea of consensus later on, but that was just to sort of query whether I'm most interested in first order or second order evidence for scientific claims. The fourth was that I made to talk to sociologists, and this was a big surprise. Are there any sociologists here today? That was great. Okay, good. Yeah, excellent. I went to an SDS meeting a couple of weeks ago, and it was very fruitful. And I gave a talk at UCL at their SDS department. It was quite brutal, but good. Different kind of audience. Now, my original view on what sociology of science was, again, not very informed, but this was sort of something I inherited from my supervisor, maybe, that we, talking about Barnes and Bloor, the Strong program, relativism, Leviathan and the air pump. These sort of, maybe again, we're talking about the extreme here. We're talking about those sort of, here's a definition of the debate, and it just gives you the extreme version rather than any nuanced version. Nuance could be hard to come by. Science is full of social, political, and cultural influences. Okay, so this is the position I had in mind. I looked at this paper by Nicholas Rasmussen, where he says the scientific truth is nothing more than what the community of scientists ends up agreeing upon. And he has this case study where he says, we ended up with this scientific truth. It's not a particular case study, I won't go into the details. Well, he says that we could just as easily, for purely sociological reasons, have gone in this other direction, and then this would be our truth. And that's just what truth is in science, where we, for purely sociological reasons, end up going. Now, again, I think that's an extreme position now, but that's what I thought sociology of science was. And I thought, well, I believe in truth in some stronger realist sense, so I must distance myself from such sociology of science. That was the. But wait, so this was the epiphany, really, which was, again, very slow coming. So for the early careers, don't make this mistake early on. And now in the book sort of spans this arc as well. The book starts with something, this book starts with something that looks more like philosophy of science, then ends up with something that looks more like sociology of science. Why? Because I got more and more interested in the scientific community as a whole and the way in which that community operates to establish scientific facts or what we should believe or probably should believe and so on. Now, the update here, since I wrote the book, is that I should have really been talking about social epistemology, which is mostly still housed within philosophy departments and done by philosophers. But I think it's a distinctive sort of subfield in its own, which is neither wholly sociology nor wholly philosophy. But a study, sometimes quite empirical, of scientific communities and their interactions, not just scientific, of course, but in this case, scientific communities, their interactions, and how knowledge gets established through large-scale communities over long periods of time, and isn't about that individual scientist making a novel prediction and it being successful, and therefore it's probably, the theory is probably approximately true. So I'll just carry on with this quote from the book. I prefer that there's second order evidence group focusing on the measure, of consensus of the relevant scientific community. And sometimes it's called the difference between internal and external evidence, the sort of first order, second order evidence. I said the shift from internal evidence to external evidence is what calls for adjustments in science education in schools, with greater emphasis on teaching the external, second order, or sociological evidence for scientific claim. And this was something that started to worry me because, as far as I could tell, this doesn't exist in the school systems in the UK or around the world. So what I said was that children really do need to leave school with much richer conceptions of expertise, consensus, and scientific community dynamics, even if this means teaching them less physics, say. So this was, I mean, it's not that there should be a balance, maybe, of, half first order science, half how does science work at the community level, but rather than, the real issue for me was that there was nothing at that community level in the school systems that I looked at, as far as I could tell. But that's something that's really important. For me, it was really important, increasingly important in my study, in my own search for scientific truth. And finally, Epiphany 5. If one wants to know whether to believe a specific scientific claim, one shouldn't ask the scientist. Again, it's something very, very surprising to me. I would fiercely have disagreed with this at the beginning of this journey. Well, let me explain this further. Maybe it's already self-explanatory from the previous 4 minutes, but I mean, here's like a case study. It's to do with David Attenborough, and he says, at university, I once asked one of my lecturers why he was not talking to us about continental drift, and I was told, sneeringly, that if I could prove there was a force that could move continents, then he might think about it. The idea was moonshine, I was informed. So this is a case of, a very capable student goes to their senior expert authority that they happen to have access to and ask them, what about continental drift? And they get the wrong answer. Now, why is this the wrong answer? It's not because this particular scientist was on one side of the debate. No. I mean, that's one thing. If you ask one scientist, you can get one perspective. But it was that this scientist wasn't willing to give the student the view of the entire expert community, or to say, here's what my community thinks, forget about what I think. Which is what we want from these senior figures. I think, in the COVID pandemic, the scientific advisor stands next to the Prime Minister perhaps, and you don't want that scientist to just give their one perspective. They're supposed to represent their community. But that's not necessarily what's going to happen if you ask a scientist. And what I say in the book is, had Sir David instead asked a philosopher, sociologist, social epistemologist, whatever you want to call them, concerned with assessing the overall community opinion, he would have been informed of an advised of a divided community. In the later 1940s, when Attenborough was at university, the overall international community was divided, but that wasn't obvious to see from any one particular vantage point at that time. It needed empirical work, really, to establish the different viewpoints of relevant scientists all over the world. In South Africa, for example, most scientists were in favour of the continental drift theory, but that was completely hidden from view for most students at the time. Nevertheless, a thorough empirical study of opinions across the world would have given you that perspective that when it comes to continental drift, however, I feel the community is divided. But of course, some scientists will always tell you that, forget about what they think, I'll tell you what the truth is. The skills needed to identify scientific facts are not the skills of the scientists. Instead, one needs, 1, a clear sense of the relevant scientific community and any virtues of that community. I'm not saying this stuff is easy, but there's different ways to carve up the relevant community, but there are good and bad ways, there are sensible ways to do that. You can do it in a couple of different ways to see if you get different results. There are also some communities that have biases. For example, some communities are more like an echo chamber than others. Some small communities only have 10 people in them, and they're all reviewing each other's papers and talking to each other. It's a problematic community in some ways. Maybe the string theory community has sometimes been described in that kind of way as a not ideal community, and some are more virtuous. Now, once you have your grip on that community and assume it's sufficiently virtuous, then you need an ability to measure the extent of any scientific consensus or scientific disagreement. Is there just an absolutely solid international scientific consensus, or is it a weak consensus? You've got sort of different pockets of disagreement which might be worth exploring, or is it like just wholly split 50-50? Well, if it is wholly split 50-50, is that different countries? Or is it just 50-50 in each country? There are all sorts of interesting different results you can get, which tell you something, I think, interesting about the status of the evidence picture overall. And then you need a story concerning the link between consensus and truth, which I'm not going to spend today going into in great detail. I'll come back to that at the end. But yeah, if you find the relevant community and it's a virtuous community, there are lots of checks and balances in there, lots of different perspectives, it's a large global community, and there's an absolutely solid scientific consensus, then what do you say to the person who says, so what? It's groupthink or something like that. So you need that story to tell as well. So this explains why, from my PhD, which I got in 2009, 15 years later, I'm publishing a paper like this, which is about how can we measure scientific community opinion and how can we do that better? So it's been a long journey, and this is the paper that we published with a large group of us in PLOS ONE in December, just gone, 2024, trying to develop a new and better way to measure scientific community opinion. And then we used this for more or less the same time, a bit of a test case to measure community opinion on the existence of alien life, which was a relatively easy case, and just it was more about testing out the methodology. But we published this in January, sort of surveying the astrobiology community on the existence of extraterrestrial life. Sort of see to what extent there's a consensus, if any, or if you want to even use the word consensus. And we've got some interesting results. In April, i.e. 2 months ago, you may have seen this big news story about potentially finding extraterrestrial life on an exoplanet called K218b. Will anybody see that story? Remember this? So this was a lot of excitement about this because there was a detection of a molecule which seemed like it probably or maybe or definitely came from some kind of life. That molecule is created by life here, for example. And what we did, because we already had this apparatus ready and we already had this database of the world's astrobiologists that we created previously, we thought we might as well survey the community opinion, because what happened in a week or two following this announcement was that people were asking scientists, what do you think? What do you think? Let's get an expert in and let's interview them. We were like, what does the community think? Nobody knows, Nobody knows if there's a weak consensus, strong consensus. We just don't have the epistemic infrastructure. That's what we're trying to build with this new model. The results we got, which are unpublished, so you can run away with these and publish them yourself if you want to, was this, which I think is an interesting view. And I think this may, so what we surveyed was scientists have probably found extraterrestrial life from exoplanet K218b with a 5-point Likert scale, and then this is your number of votes. We asked 1,300 astrobiologists, which is basically all the astrobiologists in the world that we could find, and 496 voted, so it's a pretty good sample. That's the idea, to get a good sample which is representative of community opinion. Of course, there can be sampling biases, but it's a pretty good sample. And I think this probably is the strongest sign yet of extraterrestrial life, because 6% agreed with this, which I think is significant. And only 35% strongly disagree. A lot thought, I don't strongly disagree, I just disagree. This is the kind of data that can tell us what strongest hint yet actually means. It doesn't mean it probably is, but it means that, this is a little bit exciting. And if we survey this community, from now, maybe every 2 years for the next 20 years, and assuming there are developments in the evidence and so on, then what we might be able to show with these kinds of surveys is this kind of development where over 20 years we end up with this picture. Now that could happen, who knows? It's hard to get good data from exoplanets so far away. It may just be that we're stuck saying, oh, we don't really know, we can't get the data. But this could happen. And if it does happen, so what, right? I mean, it's a consensus there. But is it just a fashion? Is it just groupthink? I won't, as I say, I won't go into this in great detail, so I'm nearly at the end of my talk now. But I agree basically with Orestes in her book, Why Trust Science. She says scientific consensus is hard to come by. And I think that's absolutely right. It doesn't come easily, and it doesn't happen for no reason. It's scientists differ, of course, like human beings. Some jump on bandwagons, some don't. Some are, fear skeptics, some not so much. There's a spread of personalities in any scientific community. And to get scientific consensus, you've got the people jumping on the bandwagon. I'm not saying there are no scientists like that. Groupthink is a thing, and it has some power. But to get a solid scientific consensus in a large, virtuous scientific community, you've got to sort of drag up some of those scientists who are really resistant to it. And the only way you're going to do that is with lots of debate and lots of solid evidence. And I think this is what we saw, for example, in the development of our understanding of atoms. The atomic hypothesis, that consensus that atoms exist in some sense, was really hard won over decades. And I think that's sort of paradigmatic of how hard won a scientific consensus really is. Because you're going to have lots of holdouts who say, look, I'll believe it when you show me sufficient evidence. There's a few quotes that I like, which sort of go with this idea. Most of the scientists are skeptics, they're disbelievers at heart, not easily won over. It's in the nature of scientists to be skeptical. Scientists and skeptics, they insist that any claim be supported by evidence, and they insist on substantial debate about the quantity and quality of that evidence before accepting it. And this one, by nature, scientists are a conservative and cautious bunch, especially when they have to come up with a consensus document. So this is just a one-slide illustration of why I think when you get a solid consensus, it does really mean something. And that's, in a sense, the end of my story, but also, obviously, the beginning.